Now this is a picture, several photos of an experiment, an open field. We call it FACE because it stands for Free Air CO2 Enrichment. The towers that you see in the background here, these are monitoring towers as well as carbon dioxide monitoring towers. To check, what they do is they release carbon dioxide into open air, not in a chamber or in a closed lab, but they release carbon dioxide, they try to maintain it at a certain level, and then they measure what is the response of crops, just like the picture down here. They release carbon dioxide at a certain level, and then they measure what is the response of the crop based on higher CO2 levels. And what they found is when carbon dioxide is 550 parts per million, crop yield expectedly went up. Rice went up 12%, the yield. The photosynthetic rate also went up. Wheat 13%, soybean went up 14%. And potatoes grown at 460, 560, and 660 ppm, likewise gave higher yields 14, 28, and 42% respectively. Likewise, sugar beet and barley, when they grew them at 550 ppm of CO2, also gave you higher yields, 6 to 8 and 8 to 14% respectively. But certain crops, very efficient crops like maize and sorghum, they did not measure any appreciable increase. That means they are rather resistant to, they're not very sensitive to increased CO2 levels. So not all crops behave like that, but generally crops will increase their yield based if the carbon dioxide is increased. However, if I stop here, it might seem like a good news, higher CO2, higher yields. But what they found out is you may get higher yields, but they got lower nutrient contents as well. So you get larger crops, heavier crops yield, but the nutrient content is lower. The yield quality has dropped. For instance, barley, wheat, rice, potato, and soybean, they found out that with higher CO2, yes, higher yields, but you get lower protein content. And for non-legumes, you get 10 to 14% decrease in protein contents. Some crops, their calcium, their magnesium, their sulfur, their content went down 2 to 20%, even though the CO2 levels is very higher at 718 parts per million. And iron and zinc, two very important nutrients, dropped 15 to 20%. Is worse for wheat than barley. And rice grown at 700 parts per million showed lower iron and zinc by 30 and 14.5% respectively, and calcium also reduced 5%. So the implication here is very large. Yes, you get higher yields, but the quality of food is lower, and because the quality, the nutrients is lower, there's a greater risk of nutrient deficiency, particularly vitamin A, iron and zinc in low-income countries. As it is now, these three nutrients is already deficient, and it affects 2 billion people worldwide, in particular in lower-income countries. So to correct this problem, farmers will probably add more fertilizers, such as to increase the nitrogen content, and if you add more nitrogen, you're going to have released more greenhouse gases. So it makes the global warming worse. Even higher temperature, higher CO2 levels, it can be counterbalanced by higher air temperature. Previously, I mentioned that higher CO2s, the yields are higher, but higher CO2s also cause higher temperatures. So at one hand, you get higher yields because of higher CO2. And then at the other hand, you get lower yields because of higher temperature. So the positive is counterbalanced by the negative. So at the end, who knows? Maybe the net effect is zero or slightly negative. So higher temperature can increase your growth rate in some cases, but it will cause higher water stress because the water consumption will increase. It will lower the nutrient use efficiency. It will lower grain filling. You get, in some cases, smaller yields, and it can encourage more weeds which are more resistant. This is air temperature, mean annual temperature for Malaysia, specifically for Malaysia. As you can see, it goes up and down, but if taken on average, it increases an average of about 0.18 degrees Celsius per 10 years or per decade. Unfortunately, this is a common trend, not just for Malaysia, but for other countries as well. Temperature will go up and down, but if you look at the overall picture, long term, 20 years or more, you will find that the temperature, mean annual temperature, is increasing slowly. Yeah? In Malaysia, it's about 0.18 degrees Celsius for every 10 years. It's about the mean, it's almost the mean Earth temperature increase for the mean Earth temperature. And climate change, especially becoming warmer, it will affect the life cycles for some of our pests and pathogens. It will make the resistance of our hosts different. The relationship between the host and pathogen will also be different because the climate is different. The insect development, because it's warmer, will increase. So more insect generations per crop season. That means more diseases, more pest problems. The epidemic, the pest disease epidemic will be worse because of the warmer temperatures. If you get more rainfall or more intense rain, you'll result in greater erosion by water. More rainfall, more erosion, worse. Lower nutrients because a lot of soil is lost. Lower soil fertility because higher erosion. If you get, on the other hand, less rainfall, you may have higher wind erosion because the soil is drier, but in the end, it's still the same. You get lower soil fertility. Again, this is for Malaysia. Let me stand. Okay, these are for different regions or different states in Malaysia. Those marked red will experience drier rainfall. The West Coast, the Klang Valley, Selangor, Johor will all experience, is expected to have drier weather, but some places, East Coast, Terengganu, Kelantan and so on, they're expected to get higher rainfall. So some areas drier, some areas wetter. And with increased global warming, Earth is warmer. When Earth is warmer, more ice will melt. When the ice melts, it will add fresh water into the sea, and the sea level will increase, will become higher. And when the sea level becomes higher, it will force water from the sea deeper inland. And as you know, seawater is very saline or salty, lots of salt, and salt is very bad for agriculture. It can kill your crops easily. Yeah? So we don't want seawater. So, but if the water level increases, the seawater will push into our groundwater, so that even though our agriculture is done away from the sea, we can still feel the effects of the seawater, the higher salinity, because the salt from the sea has encroached deeper inland. So we get our water from aquifers, from groundwater, for instance. And it can also contaminate the soil with salt. So in some countries, what they do is they wash the soil. They bring in fresh water from rivers or from lakes. They wash it they bring it into the agricultural land. They flood it to wash out the salts. But again, some places do not have the benefit of so much fresh water. But in Malaysia, generally, overall, our yield will increase if the carbon dioxide increases. But if the air temperature has to go down, if it increases, it may counterbalance the benefit of higher CO2. More rainfall, if the area is dry and you get more rainfall, this is good because it will provide more water. But you bear in mind, it may also increase the problem of pest and disease because of the wetter environment. But in less rainfall, this is good if the place has already too much rain. A good example is fruits. When the fruit trees are fruiting, you don't want too much rain. So if you get less rainfall in that fruiting season, you will get higher fruits, so higher yields. But all these factors, these conditions, they interact with one another. Higher CO2, higher yields. higher temperature, lower yields, more rainfall, less rainfall, maybe higher yields, maybe lower yields. So if you add them all up together, the net effect, that's why I put a question mark here. The net effect, we are not sure. It can be overall positive or overall negative. But specifically, some studies have been done, mainly on plantation crops in Malaysia. For rubber, it's expected that we will drop 3 to 15% in yield if the temperature goes up to 31 degrees Celsius in the mean annual temperature. But if you have higher rainfall, lesser tapping days, so lower yields by 13 to 30%. All palm, we found out that it's rather insensitive or robust to climate change. Nevertheless, it does not mean that all palm is not affected. It will be affected, especially if you get higher rainfall. You may get higher all palm yield, but if you have flooding, it's very bad for all palm. Cocoa is very sensitive to climate change. If your annual rainfall goes up 2,500 millimeters, it will decrease your yield by 10 to 20%. And if you have too much rainfall, you're going to have a lot of diseases, especially the Phytophthora and the pink diseases. And that is rainfall. If the temperature goes up 32 degrees Celsius, it will have higher moisture stress, so the yield may also drop 10 to 20%. Rice, for every 1 degree Celsius increase in temperature, rice yield will drop 9 to 10%. So this is again, it's not based on experiment, but based on model simulations, which shows that different crops react differently. So with this, I end my lecture, and I hope that you have found this useful, and thank you very much.